Previously, Lambda managed runtimes launched directly as GA releases, preventing post-GA changes that might impact production workloads. This limited the ability to address issues discovered after launch and gave third-party tools no time to validate compatibility. With managed runtimes in public preview, you can test Node.js 26 and Python 3.15 and report issues before GA while breaking changes are still possible. Third-party observability providers and deployment frameworks can validate compatibility before GA. Your functions automatically graduate to GA when ready using the same runtime identifier, requiring no action from you. Preview runtimes are not covered by Lambda SLA or support plans and should not be used for production. You can access these preview runtimes through the Lambda console, AWS CLI, CloudFormation, SAM or CDK in all commercial, GovCloud, and China regions at standard Lambda rates. When routing IoT time series data to InfluxDB databases, you typically need to write custom device code or build intermediate data pipelines to handle protocol conversion and batching. AWS IoT Core now provides a native InfluxDB rule action that eliminates this overhead. You can route time series data directly to InfluxDB databases without custom device side code or intermediate services. The rule action auto-converts your device data to InfluxDB line protocol format and writes it to either Amazon TimeStream managed or self-hosted InfluxDB clusters. You can optimize cost and throughput using two batching modes: device-side batching where devices send pre-batched payloads, or server-side batching where the IoT rules engine aggregates messages before writing. To configure this, connect your devices to AWS IoT Core and define an InfluxDB rule action with your destination database, authentication, and batching parameters. Running GPU-accelerated and compute-intensive batch workloads on EC2 infrastructure requires you to manage AMI updates, security patching, and instance lifecycle, which creates operational overhead. AWS Batch now supports Amazon ECS managed instances as a compute option to address this. You can run GPU-accelerated workloads on AWS managed infrastructure where AWS handles maintenance automatically. You eliminate operational overhead because AWS manages patching and updates for you. You create compute environments using the Create Compute Environment API or Management Console, specifying instance types and networking in the Managed Instances Provider block. You submit jobs using on-demand, spot, or reserve capacity after associating the compute environment with a job queue. This feature is available in all AWS regions where AWS Batch operates. Previously, Lambda functions required you to add permissions individually per principal, which limited flexibility for platform admins and security teams managing permissions at scale across multi-account architectures. Now, you can define permissions for multiple principals and actions in a single policy document using the full range of IAM condition keys. This means you can restrict access based on source IP or principal tag, and allow multiple services to invoke a function using a single policy rather than maintaining multiple statements. You can update resource-based policies in one step using the JSON editor in the Lambda console, AWS CLI, AWS SDK, or infrastructure as code tools like CloudFormation and SAM. This capability is available in all commercial regions at no additional charge. Regulated workloads in financial services, healthcare, and government require strict network isolation and cannot expose traffic to the public internet when communicating with AWS services. You can now create PrivateLink VPC endpoints in your VPC to establish private connectivity to Lambda MicroVMs. This enables you to call MicroVM APIs to create images or launch MicroVMs without traffic traversing the public internet. You can connect to each MicroVM's HTTP endpoint through these private connections, ensuring your data remains within your VPC boundary. You can deploy PrivateLink VPC endpoints using the AWS Management Console, AWS CLI, AWS CloudFormation, or AWS SDKs in all regions where Lambda MicroVMs is available.